Hello and welcome to Professional Tutors. We are a team of dedicated and qualified teachers whose main aim is to help you reach your full potential.
Good morning, Year 3. I'm sure this is a familiar surrounding to you. I've decided to come in and video some practical investigation work for you to have a look at, because I think this is what we do. You can see more of what's going on. You can have a better understanding because it's being practically demonstrated to you. Last week I did introduce magnetism to you, but there are a few technical issues. So having thought about that, this is what we do in science anyway. So I'll be doing a series of videos most weeks for you to have a look at, and I'll be setting you a task at the end. I've uploaded some information for you to read regarding magnetism, materials and electromagnetisms for you to see later, and some questions for you to answer. But what I thought was, we will look at how magnets, the properties of magnets, how they behave when you put them with north to north or south to south or north to south, because we can see physically what's going on. Now magnets are used in many things, from smartphones, computers, tablets, machinery, cars, all kinds of things magnets are used in. And you've got different types of magnets. I mean, here we've got different sizes, different shapes, depending on, some are stronger than others, some are only weak, some are very strong. You can have giant magnets that I discussed with you that can control cars and on the track, on roller coasters and things like that, at theme parks. But what we'll do to start with, we'll look at the magnet itself, and it's split into blue and red. We call red magnetic north. So what we will do in a laboratory situation, in a practical situation, we'd investigate them. So last week I did show you on a PowerPoint the north and the south, and we had pictures like this, and we used some keywords, and the keywords that we used were attract and repel. Attract and repel. Now, magnets, when they're in certain situations, will either attract or they will repel. And you made some predictions regarding that, because we had a picture and you said whether you thought they would attract or repel. Now, this one is a north and a south, so it's opposite. So we'd expect that to attract. If we were to change it round, and we were to say that one's a north and that one's a north, then we know that that one would repel. By having attraction and repel, as far as magnetism is concerned, that can be used for certain advantages. For example, if you want to pick something up, or if you want to stop something from happening, in the form of your roller coasters, stopping them crashing into each other. Now, I want to investigate this further, because people will use magnets to to choose between different metals, because a magnet will only stick to a certain kind of metal. Can you think of what that metal is? The metal is iron. Now, steel contains iron, so it will also stick to steel, attracted to steel. I use the correct term there. Now, when we've got lead, nothing. Brass, nothing. Aluminium, nothing. Now, you started to investigate magnets by looking around the room and checking to see which things were magnetic. You had a look at the filing cabinet, that stuck to a magnet, so that's definitely got steel, contains iron in it. Some of this probably has steel in it. Yeah, there we go, it's quite strong actually. So you looked at that. Now, we also discussed, and I've got you to draw it for me, and I had some very, very good pictures come back. I asked you to look at a magnetic field. Now, if we put a magnet on a piece of paper, like that, and we use something like iron filings. Now, iron filings are little tiny pieces of iron that have been ground down. Now this is a very good way of demonstrating the magnetic field around a magnet. Now a magnetic field is strong by the poles and it gets weaker as it goes out. And you can demonstrate the magnetic field by using these iron filings. So if we were to sprinkle the iron filings on, like so, you can actually see, that's a really good one, you actually see the magnetic field around here. And that's where it's strongest, that it's pulled away, the iron filings, from where I put it, and it's pulled it towards the poles. So you can see that the magnetic field goes around like so. And to do it even further, you could actually, I'm hoping this will work, it should do. Like so. Piece of artwork into the bargain as well. So you can see, if I was to move that away, clean that off. That was the magnetic field on the paper. Now what you could do with this, you could actually, when that was on, you could laminate that so you've got your own magnetic field, and that's something we can look at later on when we come back. But I want to move on and talk to you about something called an electromagnet. Now, I've discussed electromagnets with you. Now, if we get an iron nail, or should I say steel nail because it contains iron, and we were to wrap copper wire around the nail like so, many times. Now this is a homemade version. I want you to have a look at some big ones later where they're used in manufacturing. So if I was to wrap that copper around there, now copper is a conductor of electricity. That's why we use copper in electric wires. We use the plastic to insulate it, but copper is a very good conductor of electricity. So if we were to put electricity around this nail, it creates a magnetic force. And this can be very useful. For example, if I wanted to separate metals, and they do this in recycling centres where you've got lots of different metals together and they need to separate what they are. If they want to do that, they can use something like an electromagnet, because what the electromagnet does, once it's switched on and electricity flows through it, it becomes magnetised. Once you switch it off, then it loses its magnetic properties. And I can demonstrate this, and this is just a home kit that we've done in the lab by using a nail, by using 2 leads from the power supply. Now, I've switched this on now, and this should pick up the paper clip. There we are. It may even pick up that one. Now that is what's called an electromagnet. And these are used, as I say, in recycling places where they want to separate metals. They also use them in scrapyards because, I mean, let's look at this. That's steel. That's aluminium. You'd think that they're exactly the same metal because they're the same colour, they've got the same texture, but aluminium is an expensive material. It's an expensive metal. They make aeroplanes out of aluminium, and they make all kinds of other things. It's an expensive metal. So when people want to recycle metals, they'll use an electromagnet to separate the steel from. Now that will still be slightly magnetised. They'll use it to separate the steel from the aluminium or any other metal of that colour. So if I was to do that again now, it won't pick it up. That's the steel paper clips. If I was to plug this in, wait a second, put some electricity that goes around the copper wire, and it magnetises the nail. There we go. We may even have enough strength in this the other one. Not quite. Yeah, it's picked up the other one. Now, if I wanted to increase its magnetic force, then I could use more turns of the wire, increase the voltage, use a stronger magnet to magnetize it in the first place, and then that would then increase its magnetic properties. There we go. And that's an example of an electromagnet. It's gone off because the wire's just broken. So, to summarise, we've looked at the north and the south. The two key words that I want you to remember are attract and repel. You could take this a stage further by remembering electromagnet. These are important key words. But we've also already got magnetism, repel, attract, and electromagnet. Now, I've showed you the north and the south, so you should be familiar with attraction and if it attracts or if it repels by being the same or opposites. Just remember the word opposites attract. It's an old saying, but it is true in the case of magnets. Now, magnets are used in lots of things. I mean, a compass is a magnet, and it always points to magnetic north because the Earth is one giant magnet. The whole core of the Earth is iron, and iron is magnetized. So that is why when we use a compass, they still use them today, but if people go out into the forest, you know, they go exploring and things like that, if they get lost, the compass will point north. If they know that the station they need to get to is north, that's how it works. So today I've showed you what iron filings do with the magnet. We've drawn a magnetic field. As I say, some of you last week did this. Well done. We've also looked at materials that are attracted to a magnet, or a magnet is attracted to rather. And then I showed you how an electromagnet works. The task I want you to do for me, I've put some information onto the classroom, and there's a PowerPoint on there, a presentation of what these things are. So it talks about electromagnets. What I want you to do for me is, I want you to draw me an electromagnet. Now there's one already on there, but it'd be good if you could find a more detailed, better one for me. That's there as a guide. If you can only find that one, then that's fine, but there are plenty of images of electromagnets. So that's the first task. The second task I want from you is for you to tell me what electromagnets are used for. So there's two tasks. Draw and label the electromagnets. If you could label it, saying about the wire and things like that, that'd be great. And then find out what electromagnets are used for. Now, I will be doing more of these because we are in familiar surroundings. It's nice to be back here. It's very difficult when there's all of you want to talk to me about what you've been looking at and what you've found out. And I've noticed some of you got your plants with you, which I've been looking after. They're growing fine over here, which you did when we looked at plants earlier in the term. And as I say, we'll be doing more of these. So the next thing I want you to do is look at that presentation that I've put on there, and it describes what these do, electromagnets. I want you to draw me one, label the parts, and then tell me what different electromagnets do. See you soon.